Hello and welcome back. We will pick up from where we left off in the previous video, and in this video we will look at the part 2 of the filters. I will link the previous video in the description. Alright, so if you want to reverse any specific filter, you can use the tilde sign. So let's say we have a data frame df_diamonds and we want to filter on the column named clarity, and we want to filter all of those rows where the row contains SI. Right, so we use the same syntax. We select the column name, we add the data frame name with it, and then we do is .str.contains, and then we enclose all of it in a round bracket, and we use a tilde sign to reverse the criteria. So let's do that, and you can see that the clarity column has all of those values other than those values which contains SI. So if I want to reverse this condition, what I can do is I can remove this tilde sign, and you will see that it contains all of those rows where either the clarity column value is SI2 or SI1. Let's look at the head of the data frame again. Now let's look at some of the examples of date filtering. Let's check the column types of the data frame. So we do df_diamonds.dtypes, and we can see that our date column is in datetime 64, which is what we need in order to perform the datetime functions on the datetime column. Alright, so we import datetime as dt. We look at syntax of loc, and we can see here that we uncomment this. It's df_diamonds.loc, and then we have rows and columns separated by comma. Let me uncomment this and let's start writing up our filter. So we select df_diamonds.loc. So in the rows section, we would do is we would select a column named date, df_diamonds, and the square bracket in single quotes we type in date, and then we say greater than, and after that we are using dt.date. So within the datetime library we have lots of different functionality available on the API page of Python Pandas. Let's look at that really quick. So you can see here that .dt.date is available, and there are a lot of other available options to explore on the datetime library as well. So we do is dt.date, and then we give the parameters year, month, and day. It's easier this way because you can give it separately, and then you give it a comma so you can select the columns. And as before, if you want to return all of the columns, you can just give a colon sign and it will return all of the columns. Let's comment this and run this. Alright, so we can see that it's giving an error. Let's go to bottom to read up the error, and it says invalid comparison between dtype equals datetime 64 and date. So the problem is that this column is in datetime format, but the criteria or filter we are giving it is in a specific date format. So what we can do is we can extract the exact date format from this as well. So we do is .dt.date, and here we can see that it's giving us the results. Let me add head here, so we can see that it has filtered the data where it has filtered those rows where the year is greater than 2020, the month is 8, and the day is 31. Alright, so let me add more information on .dt.date here. So I'm pasting a link here for further reading on Pandas API website. Let me do this as a string. So select all of it and then just press single quote. Right, so let's look at example 2. We will put the syntax here as a reference again. So df_diamonds.loc, then in square brackets we put rows, comma, columns. Right, so let's look at example 2. So we put in the syntax here. So df_diamonds.loc, and then square bracket, rows, comma, columns. Please note that if we do not have the second parameter applicable, we can just skip it. So for example, we can rewrite above example as below. So df_diamonds, square bracket, we put in the criteria which is from here to here. So df_diamonds, we select the column date, and then we pull it the specific date from it by using .dt.date. Then we say greater than, and then we use dt.date, and then we put in the date criteria, which is 2020, month is 5, and day is 31st. And then we do head. So as you can see here that we have skipped this portion here, comma and colon, because we are returning all of the rows, so we don't have to specify which rows we are looking for. Moving on, what we can do is we can directly filter using date format, that is year, month and day. Please note that this has to be in the specific format, otherwise it cannot work. Please also note that the date column has to be in the date time 64 data type instead of object or any other data type. What we will do is we will put in two criteria separated with round brackets and then and ampersand sign. If we wanted to return just the specific rows, if we wanted to return rows where either of these values match, then we can use an or sign. What you do is you open a round bracket and then you type in the criteria here. So df diamonds date column is greater than 2021 August 31, and then you say and then you put in the second criteria, which is date column is less than 2021 12/1. First let's do that and filter it, and we can see here that it's pulling up rows where this data matches our desired value. So it says that it has one row which is in September, one is in November and one is in October. What we can further do is we can pull out the specific date column from it. So let's do that. Let me uncomment this and do this. So what this is doing is it's pulling out the specific date column after applying this filter on the data frame df_diamonds. So you can see here that it's doing the filter on these specific rows. Then more we can do is we can pull out the month from it. Let's do that, and we can see here that now it's pulling up the month from that specific date. Another thing we can do is once that is pulled up, we can use value counts to see how many month values are occurring how many times. So we can do dot value counts, and we see here that each of the month value is occurring once. The specific method is referred to as chaining, and we can further follow Matt Harrison for learning more on this advanced technique, as he has several videos on this topic and it's a really interesting way to do data analysis. Python Pandas also offers filter function for filtering data. Please note that the filter function only works on the column names and the column rows. It does not work on the actual data. So let's look at the head of the data first. Alright, so let's say we want to filter those specific columns or select those columns where the column name is ending with an E. What we can do is we can use regular expression, which I'm not going to go into detail in this video because it warrants a separate video by itself. But for reference, axis 1 means columns, axis 0 means rows, and we put in regular expression, and we're saying is $sign means that this is ending with an E. So we put in df_diamonds.filter, and then we give axis as 1 because we wanted to work on the columns instead of rows. Then we say head, and we can see here that it has filtered the columns in which we have the column name ending with an E. So table, price and date. Right, so let's look at example 2. We can also use filter to filter by column names. So we say df_diamonds.filter, and then we say items equals, and then we give it a list of column names we want it to filter. So we're giving it cut and carrot, and we can see here that it's filtering the two specific columns we asked it to filter. Right, we can also filter using the row label, which is basically the index. The row name is the index. So we can do is df_diamonds.filter. We say like, we give it the row name, we give it axis as 0 because we wanted to work on the rows instead of columns, and we can see here that it is pulling that specific row here, which is 11072 above here. It's pulling all of the data for that specific row. We can also do is we can set any specific column as index, and then we can pull data using that. So let's do that. So for example, we want to set the clarity column as index, so let's do that, and you can see here that now the clarity column is being referred to as our index. And then we can do is we can apply filter on it and say filter all of those rows where this clarity column has SI keyword in it. So let's do that and see if it's doing it, and you can see here that now it's filtering all those rows where the clarity column is either S1, SI1 or SI2. Alright, so lastly we have a query function from Pandas, which is quite similar to SQL if you're coming from an SQL background. So let's create a data frame using df, right? So I've taken this example directly from Pandas API page. If you want to follow it, you can go into details on the Pandas API for more practice. Alright, so syntax is very simple. You say df.query, you open round brackets, and within single quotes you mention whatever you need. So let's say you want to return columns where the column value A is greater than column value B. So you'll see that it has returned the specific row where column A's value is greater than column B. If we want to rewrite this in Pandas, pure Pandas term, it will be below, which is based on indexing. So saying df, within square brackets we put in the filter, so we're telling it to filter rows where df column A's value is greater than df column B's value. Alright, we can also use columns where there is space in it, but we have to use backticks with it. So as you can see here that it is using backticks. So we're testing or pulling those rows where the column value B is equal to column value C space C. So let's do that and see here. It's pulling up the result where the column B's value is equal to CC and just one row which is at index 0. We can see here it's pulling it here. Above can be rewritten in Pandas term as below, which is df. In square brackets we say df column B. Its value is equal to df column C space C. Alright, that's it for this video. If you like the video, please give it a like and subscribe. And if you have any questions, please post them in the comment section below. I will see you in the next video. Thank you.